Hello, everyone. Thank you for joining today's talk. I'm really honored to be part of this conference, and I would like to talk about my topic, how to bring your robot framework testing on Autopilot. I will share with you 7 examples how to optimize your productivity in test automation. Let me first start with my introduction. My name is Marcel Veselka, and I am in software testing industry for more than 20 years. Last 2 years, I am focused on building a startup, which name is Wrobocon, where we are building autonomous visual testing tools, or in general, autonomous testing tools for web apps. Before that, I was working for various banks, and last 10 years before Wrobocon, I was building a company called Tesena, where we were helping our customers to build their testing teams, their testing tools, and their test automation as well. Let me first, before I will jump into the details of the talk, start with something which might be interesting as an introduction for you. And this is something what I call signals. On the market, a lot of things are happening these days. And apart from AI, you could find also some other interesting moves. And I would like to talk about it because this is some, I would say, recent updates from various companies, but also something what I could see last 20 years, what's going on out there. So let's start with the recent reports or the reports from various companies. And as I said, I would like to share with you a couple of signals I could see on the market. And if you just explore what is reported by various companies, you might find out that, for instance, Gartner is reporting that 30% growth in area of testing will be dedicated to autonomous testing. So in 2 years, Gartner predicts that 1/3 of our testing approach will be done in a way of autonomous testing. Another interesting prediction is that, for instance, Forrester estimate that 20 to 30% of our testing productivity will be increased by deploying testing bots. And if you look at the maybe most well-known report in my social bubble or among my colleagues, more than 70% of companies are now considering what AI tools they could introduce or what AI they could introduce into the quality assurance process. So you could see that many companies are nowadays dealing with the topic of AI and productivity boost. And if you look at least at these 3 reports, most of them are searching for better testing. But as I said, last 20 of years, a lot of things happened. And let me share what I could see, what's going on the market from my point of view, if we would look a bit back and then return to the current market. So if we would look at the various stages, a couple of years ago, actually it's a couple of decades, we started manual testing where we were checking all the code, and we believed that we could find some more mistakes or bugs developers introduce in their code. Later, we found out, especially with introduction of agile and iterative approaches, that we cannot keep up anymore with manual approach. So we introduced automation. And nowadays, this approach is pretty mature. A lot of companies already adapt that, and they are proud of the achievements. And I sometimes say that automation problem is already solved. So what's the next era, or what's the next stage? Is there any like a next step to go for? Or actually, I don't know the answer, but for the purpose of the presentation, I built this slide in this way, that there will be another era where we would go into more autonomous approaches. In many reports, you could find this also as an AI augmentation testing, but I believe this is not only about the AI augmentation, even though that introducing AI heavily increase your efficiency already these days. So I'm not sure whether this is another era or it's just better test automation, but definitely there will be better tools, and we are all searching for more efficient approaches in software testing. So let me share with you some 7 ideas which could help you to optimize your productivity in test automation. And some are hard coded and some are AI driven. So I will go one by one and explain what you could consider if you are searching for some ideas, how you could introduce or how you could improve your robot framework testing. And I split these 7 ideas in various groups. I will start with some topics around technical assertions, then I will move to the visual assertions, which I call as a challenge number 1, all about assertions. And then I will be talking also about some autonomous interaction. Actually, this part will be LLM or AI driven. And this is challenge number 2, how to increase our efficiency in the topic of interaction. So let me start first with the first challenge, and that's the challenge of assertion. And imagine that you would need to test this checkout page. There is some card number details, card holder name, expiration date, and then the security code, 3-digit security code. And after submitting all these data, if they are valid, and clicking on the purchase, you would expect something like this. So that's the confirmation page where you could read, thank you for your order, your drone is flying to you, and then you have some return to store button. If I would check whether this thank you for your order is there, that could be one of the assert I would run after navigating through these screens. But imagine that this would happen. Okay, first, this is the code, and you imagine that this would happen. So instead of getting this nice, I don't know whether nice, but at least designed page with some logo, with some footer, you would get just simple white HTML page with the same text. So if I would just validate that that confirmation message contains thank you for your order, I would probably didn't catch this bug. And my question usually when I'm running this talk live or when I'm talking to some other colleagues and testing friends, I'm asking the question, what you would do to fix this issue or this risk that this bug could escape into the production? I could maybe introduce some more asserts. Maybe I could cover also assert that header is available or footer is available or button to return back to the store is available there as well. But adding this code, I'm not sure whether this would be that ideal scenario because you would introduce a couple of more asserts, I would say 4 times more assertions, but it would increase your effort to build and maintain these all asserts. And of course, this could be done across multiple tests, and then it would just blow up. So this is probably not the right approach how to tackle the problem. So let's discuss what could be another approaches. And that leads me to that technical assertions. So one of the idea I believe could help a lot to many testers running the robot framework tests is to introduce some technical assertions because these are actually not so or not exact asserts as you would validate all these availability or visibility of headers and footers, but that brings you or provides you some quality signals. So if I'm talking about technical assertions, I could suggest that you could check some status code through your test execution. So instead of writing each and every assert, you might start to introducing some global checks. So probably you don't want to get any 404 errors during your test execution. And if you need to check that, these will be the special tests. You need to handle them differently. Or you could check whether there is no some console error like JavaScript errors or warnings. Or you could check what's the loading time. And if you set some threshold, you might find out that some page is loaded super quick or super slow. So this will bring you some signals. And you could probably use these signals to measure your quality and expand your coverage. And now let me show you just very simple demo how this could work. I'm taking for this demo only one simple example where I'm checking whether there are JavaScript errors or warnings, and also checking whether there are status codes. So for that, I'm using browser library. And for those who don't know what's the browser library, it's Playwright implementation in Robot Framework. And I'm using simple keyword they implement, which is called crawl site. And this keyword basically crawl your site and then executes each and on each page specific keyword. By default, it's collecting screenshots, but I override this behavior and I introduce my own keyword, which is checking certain quality parameters, which might be status code, uh, load, like speed of loading the page, and so on. So by introducing these simple checks, I could very easily find some potential bugs. And the code would look like something like this. So we would have the crawling website test case, and then I would just log whatever would happen during that crawling. Of course, I want to limit the number of pages I want to crawl, and I want to also limit how deeply I would like to go across the website. Of course, I could make it bigger, but for the demo purposes, I just decided to have 3 pages to be crawled. And once this is done, I am getting this type of results. So I could see that page basically crawled first 10 websites and already identify one dead link. So I could get this type of tests very easily and quickly to be set up, and it could bring me some additional value where I could very quickly spot that there might be some issues. And imagine that this could not need, or this do not need to be necessarily run with crawler. You could introduce these checks as a part of your test cases. So if you have already your regression test written, you could introduce these checks across your test execution and collect various checks, which will help you to identify potential problems. In my case, I was able to catch 2 errors running this. One was because of the dead link, and the other one was some issue with external, I think it was iframe on one specific web page. So this is the example how you could introduce some additional validations across your test automation without writing too much code, because that would be across the entire test suite if you would introduce it in this way on some global level. Let me now move on to the second idea, how I could expand my coverage, or how I could add some more checks or validation into my testing approach. And that's about visual assertion. And for the visual assertion, I decided to take as an example our tool we are building, but you could use any other like Percy or Applitools or Lambda Test, or there are plenty of other tools out there. Maybe you could also consider using our open source, which we built at Tesena, which is called WatchUI. And you could check your visual quality. Let me first just quickly explain why this might be useful for you. And there are basically 2 reasons or 2 ideas what this could cover. One is increasing the coverage, so you could test much more, and I will explain this in a bit more detail. And you could also boost your coding efficiency because you don't need to code so much, or you do not need to code some complex assertions by applying visual testing. So why this might be a good idea, why visual testing could be something you should consider. And also I will tell you later why you shouldn't consider that and why this might be a stupid idea. So let's first start with this visual validation and the reason why we should consider that. So imagine that you have this type of checkout page or any other registration form or any functionality you want to validate. So what usually happens when you are running your traditional test automation, whether you are using browser library or Selenium library, you navigate through the DOM, you fill some specific elements, and then you click on pay button in this case. So once this is done and all goes well, your report is nicely green and you just continue and releasing into the production. But what might happen is that the application might be slightly or completely broken. And if this happens, then you might be in trouble because this could escape into production and your tests are still passing. So what you could do with this, there are a couple of options. One is that you collect the screenshots and then someone manually check whether the screenshots collected are correct. Or you could introduce some exploratory testing to do that and cover this by humans. But all these other approaches are not feasible if you release multiple times a day. And I know a couple of companies and some customers where they are deploying a couple of times a day into the production, and sometimes even deploying only a couple of times a day into testing environment might be the same challenging as for those who are deploying into the production. So to do this automatically, you need to introduce some tool to compare this, and there are a couple, as I said, and I'll be talking and sharing with you some examples soon what we are building. But that's not the point here. What I would like to just stress out that some bugs which might be only visual might be super critical and important for the users, but are not catched by traditional test automation. Another example, when I was talking about some boosting your efficiency, imagine that you need to test this type of registration form. So there are plenty of fields you need to fill in, and then you need to check whether the validation works. And I could write this type of test in this way. So I built something like custom assert or custom keyword to validate basically two types of fields. One is the field and another one is select. And I provide just ID as a parameter to check each and every edit box or select box. Alternative approach to this would be that I just take a screenshot, keep it as an expected result. Sometimes we call it, or often we call it baseline. And then I would just compare that screenshot with the actual one. So I could remove 12 lines of code and forget about any maintenance in the future. So I even don't need to build this because the screenshot comparison would help and work. A third use case where visual testing might be useful is when you are testing some, I wouldn't say horrible, but I would rather use the term beautiful UI, where you have a lot of charts and some visual elements, which might be pretty challenging to test with traditional assets because you could check whether the colors are there. You can check whether the width and height is basically the elements have the proper size and so on. But it would be pretty code heavy to cover all these use cases or the features. So instead of that, you just take the screenshot and compare it with that expected baseline. So these are the three reasons why maybe visual testing might be useful for you. But let me also share with you why you shouldn't consider that, or why the skeptical part of our universe looking at this approach. So what might be the reason why not to consider visual testing? It might slow down your test execution. And I wouldn't say might, I would maybe use it will slow down your test execution. Because the comparison will require to take the screenshot, store it somewhere, compare it, and then you will get back the result. Many teams do not implement this properly and then often complain about the flakiness. So there is a risk that you don't succeed with this if you don't implement it properly. And I think the strongest reason why not to do that is the third one, because if you have some manual tests, this might be good enough to catch all the visual bugs. Sometimes manual tester might be blind and do not notice, especially during the regression testing, that some button is missing or something is shifted to right or left, or you cannot scroll into some certain area. But the most horrible bugs could be catched by manual testers if they are there. If you are running some tiny small changes frequently, and you count only on test automation, then I believe visual testing is the must. But if you are running some manual exploratory or manual regression testing, then visual testing might not be the sexy topic for your test automation. Let me quickly show you how this could work. I will go through the demo where I'm using Whoppy, but as I said, many other tools are out there. And if you would be interested, I could share some list with you. But let me show you first how you could see the results in the tool. We are building some UI to use it for comparison, and you might see here 2 screenshots. On the right side, you could see the expected result, or we call it baseline, and on the left side, you could see the current image. You could see that there is a difference. Some pictures are loaded differently, and you can see also that this is reported to the users that with status unresolved and difference of 11% of the picture. And if I would just analyze the picture, I can move around, I can zoom in and zoom out and see all the details. But in this case, it's obvious. The picture is in a gallery is different. So what I could do, I could just quickly compare and see what is different. And you can see that not only the pictures, but also the moving video down in the second part of the screen is different. And why this might be useful, sometimes the visual bugs are really tiny. And if you're running heavily your regression test, you might miss these. So sometimes it's useful to use some automation for the visual testing. And for that, in Robot Framework, there are a couple of options what we offer, and I believe other vendors as well. You just install some pip package, set up your config file, and you run your tests. There are 2 approaches usually vendors and other providers follow. One is providing the listener. We sometimes call this approach semi-autonomous because you don't need to touch your code at all. You just set up in your configuration file what are the events, like if you click on button or if you fill some field, then the screenshot is taken. Or you could have like a library approach where you are using tracking keywords and adding them into your existing test cases. So how it could look like when you're running with listener, you are not touching your code. So you can see that this is the test case, typical test case for login. So you just enter the data into login, and then you are tracking whether someone clicked on any element. And whenever someone clicks on the element, we are capturing the screenshot and comparing it with the previous one. When you are running the keyword or library approach, then you just need to introduce the keyword into specific step or after the specific step where you want to check whether it works or not. Basically, in that step, the tool takes the screenshot and compare it against the expected result. Of course, then you are getting some results into standard log HTML file, and you can navigate from there into the tool for the comparing the screens. I also saw some comparison directly in the log from some other vendors, so that's also possible. In our case, there is a link. As I said, first run is just first screenshot, which you need to approve. Then the status is approved, and whenever you run, the comparison looks like this. And if there is no issue, then the status is okay. This is just very quick live demo of the same, but we basically run the run the test, and then getting the results. And if I go to our commander, you could see the test case there, including the step I checked. And for that, if I'm happy with the screenshot, I click on approve. And after approving, I'm ready for the second run. So when I'm running second time, the screenshot is already there. So what I'm doing, I now need to execute the test again. And after executing the test, I'm getting the second run. But in this case, if you would wait a bit here, then you could see that in this case, I'm comparing the screenshot again, the baseline. So I could see that there is no difference and everything is okay. So this is the second run. And then you can keep going and compare that. What happens when the screenshots are not the same? I was explaining that, so I'll skip it here and let's move on further. Just very quickly to the slide where you could see that many bugs might be found. just by screenshot testing. So you do not need to write any sophisticated and heavy asserts. Let's move on to the third part. And this will be maybe most interesting or more exciting because this will be AI driven. And I would like to talk about autonomous interactions. So what this means. I'll start again with the challenge first. So interaction, how we could build this, how we could maintain this. If you are talking to any test automation engineer or test automation professionals, you might find a lot of complaints that it's not easy to find locators, or there is no time enough to build or work on the new tests, or we spend too much on maintenance, or application change too often so we cannot maintain, and many others, and you would probably could add 10 more here. So basically, building automation or test automation is a programming task. But now, I was inspired by a couple of events last 2 or 3 years. Someone says that text is new programming language. So if we are talking about programming and text is the new programming language, then it might be easier because we all could write some standard English text, or we spend a couple of years in school to learn that. And let me show you what it's meant by that. This is AI Playground by Versal, and they offer some functionality where you could compare various models. So if you want to write something in Robot Framework, you just ask LLM model, and you could get some nice response. I don't want to now assess whether the quality is good enough. The world is changing rapidly, and I believe now it's good enough. And I'll show you why I think this is good enough to use it in our test automation. Another inspiration for me was when I saw how easy it is to write a Gherkin code using Copilot and VS Code. So you could easily write your test cases. So if you are testing login, then this is the way how it works. You just start writing the scenario name, and you are getting all the suggestion. All this gray text is suggested by GitHub Copilot. And you just keep going and adding more and more steps. You could see that some steps are underlined. And the reason for this underlining is that the steps are not defined yet. But you could easily write the test even without you just tapping or pressing tab button to get all these scenarios. So it's super simple. And I felt like, okay, what would be next? How we could go even further. So let me share with you two prototypes or two ideas I was working on, LLM driven or powered. One is form filling. It's basically simple keyword where I'm not providing too much details, almost nothing, and I expect that something will happen. I will explain the details, explain details soon. And the second one is BDD Copilot, where I was following this BDD structure and generating the instructions to Selenium or Playwright on the fly. Both are just prototypes to show you what we could build it and how easy it is. And you could introduce this into your use case. So first, let's start with the second last idea, and that's form filling on the fly. So imagine that you have this URL, this login form, and for that you would like to fill the form. And if you would go into the URL on the slide, you might find out that there is easy to log into the screen because I have, this is built just for the demo purposes. I have login name, and the password might be any string, and the login name need to be email, which ends with @tesena.com. So I run this with, I build an autonomous form filling keyword, which basically grab the HTML, send it to LLM model, and get back some instruction what should be filled in. So I've got these instructions. And once I've got that, I was able to execute the test and look at the test execution. Nothing special is there. I just fill in the data and then sign in. And I was able to sign in, and you can see log out button on the right top corner. So I'm logged in. Then I took another login screen. This was source demo, and I run the same, and I've got completely different locators and test data. In this case, I was pushing not the entire HTML, or in both cases actually, but only HTML form. So in first case, the model was able to read from the form implementation what should be filled in. In this case, it was just guess. If I would send over to the LLM model entire HTML, the instructions are below, and then it would work. So in this case, I was able, again, just fill the data, but I was not able to pass login, and the reason is because I didn't provide right context. So I would need to provide the entire HTML, and then it would work. So just example side by side. The only change I did was the URL, and I was able to get the same results. So this is something which might help you to simplify the work with locators and even with some test data. So for instance, if you would need to use some specific data like provide me any Polish IBAN to fill in this field, you could build it on top of this idea, also this type of test data generator. But let me show you how this is built and how it works. There is no magic, but I like the term magic here. So what's the magic behind form filling? I just basically write some simple robot framework code. And if you are interested in that demo or in that prototype, I can share that with you. Just reach me out after the talk. So I had this code in robot framework. Basically, these were the tests. Then I had prompt that was template, which I will share with you soon. And then I just feed the template with my data and then ask via REST API, OpenAI for the instructions. And that's it. So the prompt looks like this. I'm a test engineer writing test in robot framework using browser library. I've opened the web page and it continues. But what I provided into the template was actually the HTML and then example how I would like to get the result back. These days, you could even go further, and instead of example in JSON, you can also provide some JSON schema, so you might be 100% sure that you are getting the proper and valid data. In a bigger example or in bigger project, I found that this is super simple prompt and need to be tweaked and expand. So I have much better prompt for the production use. But for this demo purposes, this is good enough to explain and share the idea with you. So this is how it works. And for the similar situation, I built something I called BDD Copilot. And basically, I had the keywords, which I didn't implement. I just let them implement by LLM. So I passed this keyword to the LLM, and these keywords were processed, and I've got different results for these different URL. Then we could see the same video how I could log in. In this case, I believe I shared the entire HTML, so I was able to pass through the login, but I will skip this because we are running out of time a bit. And same was for the Dronjo app. So I basically built the same, but a bit different approach by running BDD or Gherkin style. After this one, I will go back to the visual testing and assertions. This is a bit crazy slide because this is not following the flow of interaction, but I felt like, okay, I already explained all the LLM ideas behind. I explained how I integrate robot framework code with REST API provided by OpenAI. And I would like to show you something what I didn't prototype, but there is some more potential using LLM for assert. So let me just show you what we could do. I took this screenshot. This is WooCommerce. It's actually a module for WordPress where you could build your own e-commerce app. And there are some demo data. And I add to the shopping cart just 2 products. And these 2 products are in the shopping cart with all the details. And it's in Slovak. Actually, I'm Slovak, so this is with Slovak localization. And what I did, I upload this to the OpenAI, and then I ask how many products are in the cart. And I've got the answer 2. And I also ask what's the amount of the order. And you could get these data from the screenshot. So this is still just very raw idea, but what you could do with the prompts and text, you could do also with images. Another example I was playing with was that I uploaded two screenshots. One was expected and the second one was actual result. And I ask what is the difference and whether there is some bug and what's the confidence of that LLM model that there is a bug. And I've got pretty nice result. So tweaking these ideas could bring us to another idea how we could boost our test automation, just integrating simple REST APIs. And if you are concerned about the costs or about the security, I'm now prototyping and building something locally, and I'm getting pretty interesting results. It's still a bit slow in compared to OpenAI REST API, but AI is coming to our local machines, so we don't need to be worried about that. But maybe I'm now just moving to my last slide, because that's about the summary, and now the statements maybe should be there. So let me just quickly summarize. I shared with you 7 ideas how you could boost or expand or enhance your efficiency in test automation. I start with very simple technical asserts which you could introduce across your testing scope or test cases. Then I move on to the visual assertions and visual testing, and I end up using pretty, at least for me, cool AI and LLM approaches where I integrate my code on the fly with REST API, where I could prompt some LLM models. And this could be done also for, I would say, 10 more other options than not only OpenAI. So this was covered in my talk. And what I would like to add are just quick summary notes. Introducing simple asserts, technical asserts, might improve your coverage and coding efficiency. And it could still be robust and could be quick. These are still just technical asserts and are just quality signals. So you might say, okay, this is not good enough, but still it expands your coverage. If we are talking, or we were talking about the interaction with LLM, there are a couple of things you need to tweak, especially temperature, because you are getting different results. You probably need to store the results and not ask all the time the same queries on the fly to make the test more consistent and repeat the same what you test last time. You might fight with context windows because many times this is something what, especially my early prototypes failing on that, when you have real world app, then the HTML might be too big. So you need to somehow optimize the HTML, minimize it, and so on. Sometimes you could struggle which model to use. Actually, GPT 3.5 is, I think this era is over. We know that now, or a few weeks ago, there was a new model, 0110, sorry, introduced by OpenAI, but there is a lot of other models popping up from Meta. There is Mistral. There is Google Gemini, and a lot of other vendors are coming there. So which model to use? That's a tough question. Sometimes you need to follow your company policy they decide it already for you, so it might be easier. But a lot of going on there. And of course, as I said, sometimes you will need to tweak your prompts because it looks like prototype might look perfect, but when you start running it against the production I mean the real world apps, you will need to tweak your prompts. At least that's my experience. So I hope I inspired you and you enjoy my talk. So that's my last slide. I would like to thank you joining me today, or us today. And I'm happy to discuss or answer your question if there are any. Thank you very much. Enjoy the rest of the conference and hopefully see you somewhere else. Thank you and bye.